So just like the earlier example I did, I've already shown you how to find the dual to this problem, but I want to go ahead and start it from the beginning. I don't want to pick up down here on the dual problem because I want you to see it all the way through. So here, let's say we want to minimize this function, and all of my constraints are in the form of greater than or equal to, so that would be a standard minimization problem. And then the coefficients of my first constraint are 2, 1, 5, and 20, so that would be my first row in the coefficient matrix. And then my second constraint is 4, 1, 1, 30, so that's my second row. And then my objective function would have 40, 12, 40 down here, and then we would have 1 for the 1C. And then you know how to transpose it, so you would transpose this matrix, and then from this transpose you actually get your dual problem, and the bottom row would be your objective function. Now remember, you change your variables, so this would be 20y1 plus 30y2 equals p. So we would have 20y1 plus 30y2 equals p, and remember, we want to maximize that. And then these three rows are going to give us our less than or equal to constraints. So we'd have 2y1 plus 4y2 is less than or equal to 40, y1 plus y2 is less than or equal to 12, and 5y1 plus y2 is less than or equal to 40. And so then that would give me these three constraints. And so now you can see that this is the dual problem. So if I ask you to demonstrate the dual problem, this is all you would give me. Would just be this maximization problem right here. Now, in order to solve this original problem, we actually have to solve this dual problem using the simplex method. So remember, we take our first constraint and we add the first slack variable to it, which actually is going to be the decision variable from the original problem. So remember, from up here we had x1, we had x2, we had x3. So we're going to add x1 as our slack variable to the first constraint, and we'll get an equation, 2y1 plus 4y2 plus x1 equals 40. And then to our second constraint, we're going to add x2 to that, so we'll get y1 plus y2 plus x2 equals 12. And then our third constraint, we're going to add x3 to that, and we'll get 5y1 plus y2 plus x3 equals 40. Now, if you don't have as many x's as you have constraints here, then you did something wrong. Because if I've got 3 less than or equal to constraints, then I should have 3 decision variables in my original minimization problem, because I got to have 1 to go with each of these. Alright, now the objective function, remember, we rewrite it by moving the terms to the left, so this would be minus 20y1 minus 30y2 plus p equals 0. Now on some of these examples I stagger these x's, but on this one I didn't do that. But it's not that difficult to put it in a tableau. So here's my initial tableau. I have a y1 column, a y2 column. I have 3 columns for the x's, x1, x2, and x3. I have a column for the p, and then my constants. So if I write the coefficients from up here, I'll get 2y1 plus 4y2 plus 1x1 equal 40. The second one gives me 1y1 plus 1y2 plus x2 equals 12. And the third one gives me 5y1 plus y2 plus x3 equals 40. And then my objective function gives me negative 20y1, negative 30y2 plus p equals 0. Now, in order for us to determine where to pivot, let's look for the most negative indicator here on the bottom row, which would be negative 30. So I would actually have to pivot on this column right here, and then I divide these numbers into their constants. So divide 4 into 40, divide 4 into 40, and I get a quotient of 10. Divide 1 into 12, and I get a quotient of 12. Divide 1 into 40, and I get a quotient of 40. Well, of these 3 quotients, the smaller quotient is 10, so that means that this would be my pivot row, which means that this 4 right here is my pivot element. So I have to pivot on that 4. So now, in order to pivot on that 4, I've got to make it a 1, so I'm going to have to multiply everything in row 1 by 1/4, and then that'll give me a new row. 2 times a fourth is a half, 4 times a fourth is 1, 1 times a fourth is a fourth, and the zeros times a fourth, they'll all be 0, and then 40 times a fourth would be 10. And then since I'm pivoting on this 1, I've got to use this 1 to eliminate this 1 below it. So I'm going to have to do minus row 1 and add it to row 2. And if I do that, I get minus a half plus 1, which gives me this half right here. And then I get minus 1 plus 1, which gives me the 0. Then I get minus a fourth plus 0, which gives me the minus 1/4. Then I get minus 0 plus 1, which is 1. And then these two right here, just minus 0 plus 0, minus 0 plus 0, just going to give me 0 here and here. And then minus 10 plus 12 is going to give me 2. And now I also need to get rid of this 1 in the third row, so I'll do minus row 1 and add it to row 3. So I have minus a half plus 5. Well, that will be 9 halves because 5 is 10 halves, so minus a half plus 10 halves is 9 halves. And then minus 1 plus 1 gives me 0. And then minus a fourth plus 0 gives me minus a fourth. Minus 0 plus 0 is 0. Minus 0 plus 1 is 1. Minus 0 plus 0 is 0. And then minus 10 plus 40 gives me 30. And then the last step, I got to get rid of this negative 30. So I have to multiply row 1 by 30 and add it to the fourth row. So if I multiply everything by 30 here and add it to row 4, this is what's going to happen. A half times 30 is 15, and 15 plus negative 20 is negative 5. 1 times 30 plus negative 30 is just going to be 0. 30 times a fourth, that's the same as 15 halves. So add that to 0 and I get 15 halves. 30 times 0 plus 0 is just going to give me 0. 30 times 0 plus, let's see where I'm at. Okay. 30 times 0 plus 0 is going to give me 0 again. 30 times 0 plus 1 is going to give me 1. And then 30 times 10 is going to give me 300, and 300 plus 0 is 300. So I've completed the first pivot. So I'm looking now at the bottom row, and I see I've still got a negative on the bottom row. So I'm not done yet. So I haven't found the optimal solution. So let me go ahead and pick back up here. Since I have a negative on that bottom row on the first column, that's got to be my pivot column. And then I'm going to divide a half into 10. So 10 divided by half would be 20. And then divide a half into 2. 2 divided by half would be 4. And then 30 divided by 9 halves would be 30 times 2 ninths, which is 60 over 9, which is 6 point something. So 4 obviously is going to be the smaller number. So that identifies the second row as the pivot row. And then that means I've got to pivot on this 1/2 right here. And so in order to pivot on this 1/2, I've got to multiply this row by 2. So multiply everything in this row by 2. And you'll get a 1 here, a 0 here, negative 1/2 here, a 2 here, a 0 here, a 0 here, and a 4. And remember, I'm pivoting on this 1. So now I want to get rid of this 1/2. So I'm going to multiply negative 1/2 times row 2 and add it to row 1 to cancel the half. So let's do that. Negative a half times 1 plus a half, that's going to give me 0 right there. And then negative a half times 0 plus 1 will give me a 1 here. Okay, now it might get a little trickier. Negative a half times negative a half is positive 1/4, and 1/4 plus 1/4 is 2/4, which is a half. And then negative a half times 2 is negative 1, and I have to add that to 0, so I'll get negative 1 right there. And then when I multiply these by negative a half, I'm just going to get 0 and add it to 0. So both of these, when I do these, it's not going to change it. I'm just still going to have 0 here and 0 here. And then finally, negative a half times 4 is negative 2, and negative 2 plus 10 is going to give me 8 for the constant. Okay, now I need to get rid of this 9 halves. So I multiply row 2 by negative 9 halves and add it to row 3. So negative 9 halves times 1 is negative 9 halves, plus 9 halves gives me a 0 in this spot here. And then negative 9 halves times 0 plus 0 is 0. Now let's see if we can do this in our head. Negative 9 halves times negative 1 half would be positive 9 over 4. And then if we add that to negative 1 over 4, that would give me 8 over 4, which would give me 2. Then negative 9 halves times 2, that would just give me negative 9, and then add it to 0, and I get negative 9. Then negative 9 halves times 0 is 0. Add it to 1, I get this 1 right here. Negative 9 halves times 0 plus 0 is just going to give me 0. And then negative 9 halves times 4, that would be negative 36 divided by 2. So that would be negative 18. And negative 18 plus 30 gives me 12. And then finally, I need to use this to get rid of the negative 5. So I have to multiply row 2 by 5 and add it to row 4. So let's do that. 5 times 1 plus negative 5 gives me 0 here. 5 times 0 added to 0 gives me 0 here. Now 5 times negative a half would be negative 5 halves. Now stay with me here. Negative 5 halves plus 15 halves would be 10 halves, and 10 halves is just 5. And then negative 5, not negative anything. 5 times 2 is 10, and then 10 plus 0 is 10. And then 5 times 0 plus 0 is 0. And then 5 times 0 plus 1 is 1. And then 5 times 4 would be 20, and add 20 to 300, and you get 320. So now notice in this tableau I do not have any more negatives on the bottom row, and since my solution to the dual problem would be P equals 320, then the optimal solution to the original minimization problem must be that C is also 320. But now if I want to find the x values, remember we got to look at the bottom of these columns. So here's the x1 column. So notice at the bottom of that column you have 5. So x1 is 5. And then the x2 column, let's look at the bottom of the x2 column, and notice at the bottom of the x2 column you get 10. See right here? And then look at the bottom of the x3 column to get that solution, and notice that when you look at the bottom of that column you get 0. So x1 is 5, as I said, x2 is 10, and then x3, as you can see here, is 0. So the solution would be x1 is 5, x2 is 10, x3 is 0, and the minimum is C equals 320. And remember, this is the solution to the original problem that we started with way up here. So that would be the solution to that problem. Okay. All right. So anyway, that's the solution to the problem that we started with. 5 for x1, 10 for x2, 0 for x3, and the original problem has a minimum value of 320. I've got a couple more examples that I'll show you on the next video. So I've got several of these examples I can show you, so let me show you these next two on the next video.